This is my Earth series talks. This episode is numbered 14. My subject today is magma chamber. I'm talking about volcanoes. A magma chamber is an area beneath the Earth's surface where magma, it is also known as molten rock, collects in a pool of molten rock. Magma forms in subduction zones where an oceanic plate is overridden by another crustal plate. The descending plate begins to melt and the molten rock collects in these underground chambers. The magma is hotter than the surrounding rocks and is under great pressure. The melting plates continues to add molten rock to the chamber, increasing the pressure until it breaks the solid rock apart. The hot liquid rock is lighter than the surrounding rock, so the magma forces its way upward where it can erupt during a volcanic eruption. Magma chambers are detected using earthquake waves. That is, primary waves travel slower when traveling through liquids than through solid rock. Scientists use the speed of these waves to determine the shape and size of these magma chambers. Most known chambers of molten rock are between 1 and 10 miles deep. Little is known about deeper chambers because they are hard to detect. Some magma travels through two chambers on its way to the Earth's surface. The bottom chamber feeds an upper chamber near the summit of a volcano. In the Hawaiian island, scientists study harmonic tremors, special earthquake waves that indicate movement of magma into a chamber near the summit of Kilauea and Mauna Loa volcanoes. On the islands of Hawaii, harmonic tremors often precede a volcanic eruption. Magma that remains in a chamber for a long period of time begins to cool near the walls of the chamber. Olivine is one of the first minerals to crystallize in a magma chamber. The elements that make up the mineral are taken from the melt as gases are released from the crystallizing elements. So I've got a video animation for you on the magma chamber. It's beautifully made. I would like you to see.
Where magma, which is melted rock from the Earth's interior, emerges, a volcano is formed. Initially, the rock is melted deep under the surface in the magma chamber. If the pressure in the chamber is greater than that from the overlying layers, an eruption causes the formation of a new volcano, or the reactivation of an existing one. Based on the type of eruption, scientists distinguish between central volcanoes, fissure volcanoes, and other types of volcanic events, such as hot springs or gas exhalations.